Today's topic is inequalities. So here's the deal. Most of the time in Algebra 1, you deal with things that are exactly equal, but we do talk a little bit about situations where things are not identical, where things are larger or smaller than each other. And we illustrate that often using these symbols. This guy being the greater than or equal to in this specific situation, and this guy being the less than, right? We look at those as they are. And what we're going to talk about today is we're going to talk about how to illustrate those particular symbols, what they mean, and we're going to talk about how to solve equations that aren't actually equations, but inequalities. They're going to be set up the exact same way as the equations we've seen before, but they're going to have these symbols, one of these, included in their setup. And so we're going to have to learn how to deal with solving an inequality. It is possible to do, and it's possible to express that inequality in a way that makes good sense. So first, before we get into solving them, why don't we talk about how to illustrate them, how to represent that the values that are present in our inequality have meaning. The most common way to illustrate an inequality is to start with a number line. So let's do that. Let's draw out a straight line here, and let's put some tick marks on that straight line. Okay, some tick marks there, right? And we're going to represent each of these tick marks with different numerical values. So let's say this is 5, this is 6, this is 7, this is 8, this is 9, 10, 11, and 12, right? We've got our numerical values set up there, number line extending in both directions. And this says that x is larger than or equal to 8. Now, if it's larger than 8, that's going to be numbers like 9, 10, 11, and 12, everything that is headed in that general direction. If it's equal to 8, it's going to have to be exactly here. So the way we're going to illustrate that, the way we're going to represent the idea that x is greater than or equal to 8, so we're going to start with a circle, nice, dark, shaded in circle, right at 8. And then we're going to draw an arrow in this direction, shade that nicely so that it's very clear what direction we're going, and give it an arrowhead, just like that. Okay? That's for greater than or equal to. Greater than or equal to. That symbol there. The next one says y less than -1. Let me switch to red again. Once again, we're going to start the same way. Sketch out this nice long line. Put some tick marks into that sketch. Okay, and then we're going to label those. So let's make this -5, -4, -3, -2, -1, 0, 1, and 2. And we might set it up like this. I'm going to switch to my blue color so that I can indicate y less than -1. A number smaller than -1 would be something to the left on the number line. So -2, -5, -10, something like that. Those are all going to be smaller than -1. But we have to set it up so that everything that is smaller than -1 gets included. And that's going to include things like -1.5, -1.1, -1.0001, -1.000000001. So everything that exists that is to the left of -1 has to get included, but not -1. So we've got to do something different to how we set up the +8 expression up here. Here we colored in a solid circle and went to the right to indicate greater than or equal to 8. That included 8, and then it was everything bigger. Here, we're going to be very different, but very intentional with how we represent this. We're going to put an open circle on that -1, and then we're going to do the same kind of thing. We're going to color in all of the stuff going to our left. Okay? Going to our left. And we're going to draw an arrow so that it implies that we're going infinitely to the left. Okay? So we've got this open circle here, which means not -1 included, but everything to the left. Now, obviously, this is useful, but not necessarily very, very concise, not very easy to read. And so mathematicians came up with another way to say the exact same thing, something that could be typed or written and was easily understood. That thing is called interval notation. Interval notation. Sorry, my handwriting is going a little wonky here. Interval notation. And the way interval notation is going to work is we're going to take something like this. Let me get my black marker here. We're going to take something like this, x greater than or equal to 8, and we're going to try to find a way to represent it using just numbers. And the way we do this is we're going to say that 8, comma, infinity, and we're going to put a parentheses around that. Oh wow, that was bad. Let me try that again. We're going to close parentheses around this end, but around this end we're going to use a bracket. And I'll explain what those mean in a second. And then for the bottom one, y less than -1, we're going to start with a negative infinity symbol. And then we're going to put a -1 here. And we're going to open with parentheses and we're going to close with parentheses. And what this is going to mean is if I have a bracket around a number, that means that that number is included and is either the starting point if it's on the left, or it's the ending point on the right. So here, because I started with 8 in my graph, because it's x greater than or equal to 8, since that's where I started, I opened with a bracket, and then it extends forever to the right, so I'm closing with infinity. And infinity is not a number, it's an idea. It's something that's going on forever. It's never stopping. So we can't close with a bracket because you can never reach infinity. It's just going to keep going and 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 going. That's how infinity works. Okay? So if you ever have infinity, either at the beginning with the negative infinity, or at the end with the positive infinity, it always takes a parentheses, regardless of whatever else your picture looks like. Infinity always gets parentheses. But if you've got a solid number with a closed circle, like we're equal to something, you take a bracket. If there's a number we're starting with that doesn't get included, okay, that means that we close or start with a parentheses. So most of the time we use parentheses. The only time we use brackets is if we're stopping at a number or starting with a number. Okay? So that's the difference here. Okay? And I'm going to try to give you both values for these next examples that we're going to be looking at here in a second. First though, a quick break.
Oops.
I need to change the color on my Legiona armor so that it matches my my cat's Nergigante stuff.
Yeah.
I'm fine.
Jeff is confident. Too confident.
Oh, it's all muddy. Where's the other one? Are they both in the
The other one spawns when you kill the first one.
Oh. What am I waiting for then? Come here, big boy. Alright, he's digging.
Oh!
He immediately started by ramming into the barrel. The barrel's just having a bad day.
That barrel has
Is there a piece of candy over here already?
Probably.
probably from the
The
barrel.
barrel
Yeah.
has taken a bunch of damage already in this fight.
What does this do?
That
that's the
missed.
rock. I didn't know what it did. I'm sorry.
Oh, okay. You came to pay me a visit.
Oh, the barrel is dead.
We killed it already?
Boss, the Diablos killed it.
I mean, you're not wrong.
Diablos like flung it across the map.
Oh, he still hit me. I want a dragon.
Here's the other barrel.
Oh, he decided to come join the party.
I'll go ahead and heal up with one of these mega potions I've got sitting around.
Oh my!
That was good. That was good. That was good. Going there on, don't stop. Oh, this is gonna start. Turf war.
I think there's a turf war going on.
Did anybody see what just happened?
They collided.
They tried to ram each other's heads in. And
And the
only
barrel
one of them
lost
won.
significantly. Oh
Oh, I couldn't get high enough.
Oh! We killed the Baron! I was
What?
flying into the air and killed the Baron!
Oh.
no! I hit the barrel.
Nope.
Well,
Alright, now this is just normal Diablo.
no!
I'm chasing him down. Whee! I broke something. Oh, there's his horn!
leg.
How did I break his horn?
You can't attack
his
his
legs.
legs.
Is he digging? He's digging.
Video game, please.
Hi, sir.
He's a digging.
No, whoa, sir.
Alright, that's probably good. Oh, dang it.
Stop
Oh, I
digging,
got her!
please.
I hit him once! Shots.
Oh,
Oh, dang it, I got kicked out.
Are we gonna dig? Yeah.
Yep.
He's gotta stop doing that. Nope.
Oh,
Yeah.
Gonna dig again. Yep.
Nope.
Dig again.
ah!
I get hurt. You quit digging.
I'm stunned. I'm stunned.
Oh, I got you.
All right, I'm good. I'm good. Oh, didn't.
Well,
work.
technically, you're good.
Also, the fact that my axe is me attaching my shield to the end of my sword is really cool.
Okay.
1 damage.
I
Damage at a time.
I tapped him. I tapped his leg and he died. Alright. Hope you enjoyed your break. We're picking back up with our first example. Here's an inequality, just like I promised you. we're going to have to start doing some actual solution. And we're going to treat it the exact same way that we've been treating our equations in our previous lessons. We're going to start by doing some opposite processes. Let's move this plus 1 over to this negative 17. Let's subtract 1, subtract 1. That goes away. We get 5x greater than 7x. Negative 17 minus 1 gives us a negative 18. Negative 18. Then we need to do opposite of this. This is a positive 7x, so we're going to subtract 7x. 7x minus 7x cancels. 5x minus 7x is going to give us a negative 2x. So negative 2x is larger than negative 18. Alright, and we're going to get our first big trick here. This was not intentional. I did not mean to do this. This might, in editing, I might change the way I do this a little bit because this is a little complicated. But when we divide, specifically in situations where we divide with a negative number, if I divide by negative 2, okay, that's going to force us to do something special and unique to our symbol. First of all, let's just figure out what the math is. Negative 18 divided by negative 2, it's going to make a positive 9. That's a positive 9 for our solution here. But because I'm dividing with a negative number, there's a very special rule that only applies for inequalities like this. If I started with a greater than symbol and I divide by a negative number, the solution has to change direction and change equality. So if I was at greater than, it's going to now become a less than, and since I had no equals, I'm now going to have an equals. Okay? This is, again, unique to situations where I have negative coefficients that are being divided on both sides. I change the direction, and I change equality. So x is now less than or equal to positive 9. And as promised, I'm going to illustrate it with a number line. And I'm also going to illustrate it with interval notation. So first I'm going to give you interval notation, and then I'm going to show you what it's going to look like on the graph. Interval notation in this case is going to be negative infinity, comma, 9. 9's going to get a bracket. And of course, negative infinity always gets a parentheses. And I know this is true because I'm including 9, so I get the bracket, and x has got to be smaller than 9, so I've got to start with negative infinity. Okay, I've got to start in that general direction, in the left direction, and I'm going to stop at 9. So let's see what this looks like graphically, and hopefully between the two you'll start to see how this makes sense. Okay. And let me just make this 9, 10, 11. And let me make this 8, 7, and 6. And because it's x less than or equal to 9, that means all numbers smaller than 9 get included. Okay? So that means everything in this direction. And because it's equal to 9, I've got to put that nice closed circle on the 9 divot, and then draw my arrow to the left. Okay, something that looks like that. So going to the left, just like that, that's our situation, that's our graph, and this is our interval notation. Either of these would be, either of these are going to be a, nope. Either of these are going to be a valid solution for our inequality. Okay? One more, maybe two. Let me look and see how much time I've got. 21n minus 3, 5n plus 9 greater than or equal to 7. All of that in a big package. Again, we've got to solve it out just like we would with a normal equation. So we've got 21n, and we've got to distribute this 3. This negative 3 gets multiplied by 5, so negative 15n. And then negative 3 times positive 9 gives us a negative 27. And it's greater than or equal to 7. Now, let's combine some like terms. 21n minus 15n. That's going to give me a 6n minus 27 greater than or equal to 7. Okay. And then we've got this situation here. Let's add 27 to both sides. And we've got 6n greater than or equal to, and that's going to end up being 34. So 6n greater than or equal to 34. Got to divide by 6. 6. Did I do something wrong? I got to check and make sure. Don't think I did. Okay. So n is going to be greater than or equal to 34 over 6 or 17 over 3. And that reduces. Okay. So, ways we can set this up. Once again, we'll start with the interval notation. It's going to be 17 over 3 with a bracket around it because we've got that greater than or equal to symbol. And then because it's greater than, that means that to the right, I'm going to have positive infinity, parentheses. Okay? Infinity for now always gets parentheses. 17 thirds, because it's equal to, gets a bracket. And if I wanted to sketch that out, let's say I draw my arrow here. Okay. Because it's 17 thirds, I'm going to cheat a little bit here. Let me spread those out a little bit more. It'll be easier to write if I have a little more space. So let me put 17 thirds here. We'll make this one 18 thirds or 6. And this one's going to be 19 thirds. This will be 16 thirds. And this will be 15 thirds or 5. Okay. Hopefully that makes sense. And because we're x, or n rather, being greater than or equal to 17 thirds, I've got to put a closed circle again right on that 17 thirds. And then I need to go to the right. Everything that is larger than 17 thirds gets included, just like that. Okay. Yeah, one more. I've got time. And I think this will be good. This will be very good. We've got 12s plus 52. Don't really have anything that I have to do on the left, but I do have a distributive property situation to take care of on the right. So negative 2 times 4 gives me negative 8. Negative 2 times negative 2 gives me positive 4s. Okay, very good. And now I need to take a second and move some things around. Let's move 4s over to the other side. And let's move negative 52 over to this side. That's going to cancel there. That's going to cancel there. 12s minus 4s is going to be 8s greater than negative 8 minus 52. Both of those are negative numbers, so we add the values, keep that negative sign. We get negative 60. And now we need to divide by 8. S is going to be greater than. Both of those are divisible by 4, so let's say negative 15 over 2. Negative 15 halves. This time I'm going to start with the graph. Okay, graph. It's going to look something like this. And just like with the last one, I'm going to put the fraction dead center, the negative 15 halves. Let's see, this is probably a good spot for it. Okay. And in this direction, we're going to have negative 14 halves, or negative 7, and then negative 13 halves. And then in this direction, we're going to have negative 16 halves, or negative 8, negative 17 halves, and negative 9. And let me switch to red for our mark. S is greater than negative 15 halves, which means we need to go in the right direction. We're going to start here, but because it's not equal to, we've got to put an open circle there. We've got to put an open circle. And then we're going to sketch by drawing this nice shaded arrow to the right. Okay. Hopefully that helps. Hopefully that's clear. Oh, wait, sorry. Before I wrap things up. One more quick little thing. We've got to get that interval notation, and this time, again, it's pretty straightforward. Negative 15 halves, comma, positive infinity. And because it's not equal to, we've got to put a nice open parentheses, right? And then close parentheses, because we always put parentheses on infinity. We never put brackets there. Okay, that's everything. That's the answer. We've got our arrow pointed, and we've got our interval notation done. Hopefully that helps. Good luck on your homework. And looking forward to hearing from you guys very soon.